Hello, and welcome to the second video portion for the Drawings Lab. Today, we're going to be covering assembly drawings. A good example of an assembly drawing is an IKEA instruction manual. We take an assembly, tear it apart, draw lines connecting the pieces together, and then give each piece a part number. Let's begin with our assembly. Here, I have the robotic arm that we were using earlier. We're going to begin on the Assemblies tab, and then select Exploded View. Assembly drawings are often presented in pictorials, so it can be handy to set our view to a pictorial. In this case, choosing the trimetric option from the drop-down here tends to work well. Alright, now from here, we just need to select a part by left-clicking on it, and then we can drag it in a direction specified on the gimbal. Once it's moved to a position that we're happy with, we can select Done, and continue on to the next parts. Similar to detail drawings, creating explode drawings can be more of an art than a science. The exact distance that you move components doesn't matter. Your end goal is to have it so that all of the parts are separated, with minimal overlapping. You want it to be clear where each part is, and where each part goes. Some things make more sense to explode together, like removing the majority of the arm from the base. You can left-click to select multiple components, and then once we do have everything selected, we can left-click drag on the gimbal to move all of it at once. Hitting Done, we can then continue to the next step. Some pieces, like these arm joints, aren't going to cleanly move in one of the three primary directions. In that case, once you have all of your components selected, we can choose a different direction by selecting this box here, and then choosing an edge, or a surface that defines a direction. And from there we can left-click drag on the arrow to move, just as we had before. Hit Done from the menu, and repeat until all of the components have been separated. Some components, especially these joints, can be particularly troublesome to select a good direction for. In cases like this, once you have the part selected, you can activate the mini design tree, and then find a primary plane or piece of reference geometry that we can use. In this case, the right plane functions well. From here, we can left-click drag to move, and continue on. There we go. I've taken the liberty of continuing along, and now that we're all finished, we can just hit the check mark up at the top left, and we're done with our first step. Alright, actually, looking back at this, we've still got some work to do. The switches are still stuck to the base. The ordering on the gripper in this joint are a little off, and we haven't even touched the gripper yet. To re-enter and explode, we can go over to the Configurations tab, hit the drop-down below the configuration that we're working within currently, and then right-click Edit on the Explode. Explodes are kind of like sub-configurations. Each configuration can have any number of explodes, and you can activate or deactivate an explode by selecting Collapse or Explode on the right-click menu. Anyway, back to editing. How should we go about this? First up, adding the switches is fairly easy, as we can just treat these like any other explode step. We'll select our components, and once we have that done, we can just left-click drag on the arrow to move them all upwards. From here we'll hit Done, and we're good. As a side note, SolidWorks keeps track of the order that you exploded your parts in, and these explode steps can be rearranged by left-click dragging them in the Explode Steps section. In this circumstance, it doesn't really do much to change the current layout, but it can be useful when producing an explosion animation, something that will be left to the astute viewer to explore. Editing the joint in the gripper gets a little bit more complex, but nothing too crazy. By left-clicking on an explode step, you can then increase or decrease the distance that the component has been exploded by left-click dragging on the gimbal. So you can move the hand to here, move the joint a little bit further up, and that looks a lot better. Lastly, the gripper. There are two general ways that you can handle this. On the Explode menu, we can check the Select Subassembly Parts option down at the bottom, and this allows us to select individual components within a subassembly. Our other option is to go into the subassembly itself and create a sub-explode that is only going to affect the gripper. If we do this, SolidWorks allows us to import that explosion into anywhere else that gripper might appear. Or we could have it as a separate view on the explode drawing to keep it from cluttering up the main explode. The second option tends to be more versatile, so let's try that. Here I have our gripper open, and a new explode started. There are two ways that we can approach this. Let's begin by checking the Auto Space Components option, and we're going to start by moving the tendons and the wrist joints backwards. With all of the components selected, we can then left-click drag on the gimbal, and we can see that SolidWorks is going to automatically space the components for us. We can change the order that the components are moved by cycling through these three options, which measure based on the center point, the back, or the front of the bounding boxes of each component. Oftentimes it's best to just try all three and see which one makes the most sense. Another approach that we can take is using the radial step option. From here, we can choose the 3 finger lengths and the tips for the 3 fingers, and then it will automatically generate an axis. Left-click drag on the arrow that it gives us, and all 3 of the fingers move an equal distance away from the generated axis. From here, we just need to explode the fingertips of all three of these forward, and then we can wrap up by exploding the switch vertically. Now that our explode has been completed, all that we need to do is add our explode lines. There are a couple of different ways that you can do this, but the easiest option tends to be Insert, Edit, Smart Explode Lines. However, this can also be the most finicky, depending on how you performed your explode. Let's give it a shot. Immediately, we see the yellow preview lines are generated to show how each explode line will be placed. Each part that was moved gets an explode line that's automatically generated based on the movement steps provided. You can select an explode line by left-clicking on the purple dot, and then from here we can define where the explode line originates. We can choose between the center point of the bounding box, the origin of the component, or we can choose a point manually. For components that were patterned, we also have the option to apply that to all component instances, which is going to automatically move the explode lines for each of the three finger joints. Some of the explode lines that are generated, like those for the fingertips and for the tendons, aren't particularly useful. We can remove those lines by right-clicking on the component from the components list and selecting Delete. We're going to end up just having to add those in manually. Now that we have that sorted, we can hit our green checkbox and continue on to adding our manual explode lines. To generate these, we can hit the drop-down below Exploded View and select Explode Line Sketch. From here, it's a fairly straightforward process. We can select two points, cylinders, or surfaces, check and uncheck boxes as needed, and hit the green checkbox to place. We're going to continue on until each component has been properly connected with its neighbors. Remember, the purpose of explode lines is to show how these components are connected together. Try to ensure that the explode lines are as clear as possible. Oftentimes, this may mean unchecking the along XYZ box. Okay, now that our gripper is done, we can save and pop back over to our main assembly. From here, we can go back into our explode view. For the arm, select Edit, choose our subassembly, scroll to the bottom, and select From Subassembly, which is going to carry over the explosion steps that we had just covered, and place them in with the context of the main model. However, in this case, it does leave the overall model pretty cluttered, so it will probably work better to have the gripper set aside on a separate view in the explode drawing, so I'm just going to right-click and delete that to undo our change. In any case, with all of that set, I'm going to go through the process of adding the explode lines to our main assembly, and then we can go about creating our assembly drawing. Fortunately for us, creating the assembly drawing is pretty much the easiest step. First, save your assembly, make sure to rebuild as necessary, and then from here, we're going to open up a new drawing document. I'm going to set mine to a custom sheet size, and we'll do 8.5 inches wide by 11 inches tall, to make sure that we set it to a portrait view, which ought to be better for the tall model. We'll hit the arm assembly from our menu, hit the right button to choose our views, and from here, it's fairly similar, but we see that we also have a new option. We want to make sure that the Show an Exploded or Model Break State box is checked, and from here we can choose the explode state that we want to use. As mentioned earlier, you can have multiple exploded views for the same assembly, but here we only need the one. This feature is often useful for very complex assemblies, such as an engine block or an airplane. In either of those cases, seeing thousands of parts blown out all at once would just be confusing, and would not assist in knowing how the assembly is put together, so it can be best to explode sub-assemblies separately. As mentioned previously, exploded views are often going to be in pictorial projections, so we'll want to make sure that we have our trimetric option selected, and then we consider display state to shaded with edges. Since color is often used as a convenient way to differentiate parts in assemblies, it can be useful to show the color in the assembly drawing. With that, we can left-click to place our exploded view on the sheet. It's pretty small here, with a lot of wasted space, so we're going to have to increase the scale to get a better look at what's going on. This works the same as increasing the scale of a detail drawing view, so we can just left-click on the exploded view, scroll down to Scale, set it to use custom sheet size, and type in a value that makes sense. In this case, 1 to 8 will work well. If your model is more wide than tall, it can be useful to change the aspect ratio of your drawing via right-clicking on the sheet and selecting Properties. As shown earlier, the aspect ratio can be changed by swapping the width and the height values. Now that we have our first view imported, we can go back up to Model Items, select our rotational gripper, hit our Next button, check to show it in the break state, make sure it's set to trimetric, set our display style to shaded with edges, and then left-click to place. Now we just need to add the bill of materials and call out balloons. Let's do the bill of materials first. We can hold down the Control key and left-click to select the two views that we want the bill of materials to count, and from here we can go to the Annotations tab, hit the drop-down below Tables, and select Bill of Materials. Importantly, up at the top, we can choose how parts are counted. You want to make sure that your BOM type is set properly. In this case, indented functions well. This is going to dig through each subassembly to make sure that we're showing each of the individual parts. With more complex assemblies, you may want to leave it at top level only, in which case it will list the entire subassembly as an individual part. We're also going to want to make sure that we have our numbering set to detailed numbering, which is going to include information on which assembly it's coming from. Hit our checkbox, and then we can left-click to place it. We can see that this is going to give an item number to each of the individual pieces, and it's also going to list the file name, brief description, and the quantity. For our purposes, the description column usually isn't going to be particularly important, so we can delete it by selecting the letter that pops up above the description section and hitting the delete key. Now, all we need is something connecting these item numbers to the actual components in the exploded views. For this, we're going to use the Auto Balloon tool. This is going to automatically generate numbered balloons that connect to each part in your model, but they're generally not very well placed, and on occasion may be skipped altogether. Once you've hit the checkbox up at the top left, we can left-click drag on the numbered balloons to move them to places where they are on the page and more easily readable. In cases where parts get skipped, we can hit the balloon button up here, and then left-click on the component that we want to have the balloon connected to. Remember, the point of these drawings is to be helpful. We want to make sure that it's obvious which component each balloon is connected to, and a tangled mess of numbers and leaders doesn't really help anybody. On occasion, when balloons are added to a subassembly, the numbering on these balloons might be disjointed from the numbering on the bill of materials that we had generated. To fix this, what we're going to need to do is right-click on that view of the subassembly, select Properties, and then check the Link Balloons to Text and Specified Table box. Hit OK, and we'll see that the numbering on these new balloons has been updated to match up with the bill of materials that we had generated earlier. Do a quick sweep to make sure that we didn't accidentally miss any components, so ensure that all of the numbers that are shown in your table are specified on one of the balloons, and we're done. Well, with that, we've completed our assembly drawing. Make sure that you save it somewhere safe, and use Pack and Go if you intend on sending the drawing to someone else. That about covers everything that I had for today. Have a good day. We'll see you again next time.